In today's math lesson, we're going to factor quadratics with a leading coefficient of 1. As we get this process started, I want you to take a deep breath and realize this is going to be okay. I promise you the pathway that we walk down is going to be consistent and easy to maneuver each and every problem. So let's begin this together. You're going to be given a quadratic, and you have to acknowledge what your A, B, and C numbers are. A and B are both coefficients, while C is a constant. And in this particular lesson, our A coefficient is going to be 1 every time. So we're going to go forward from there. At this point in this problem-solving process, we are going to use one of two graphic organizers. Our first graphic organizer is just a box with a big X through it corner to corner. In the top triangle, we are going to look at the product of our A number times our C number, and that's going to go right here. In our bottom triangle, we are going to place our B number, nice and simple. In our second graphic organizer, we draw a tall capital T. It's a T-chart. And at the top of that T-chart, we're going to place whatever we got from the product of A times C that's living here in the top triangle of our box, here at the top of your T-chart. And using this T-chart, you are going to list out all the different possible pairs, all the different factors of numbers that could have been used to create this value of A times C. From there, we are going to find the magic that's been needed by adding each of these pairs of factors together, whatever they are, and you're going to get something. Who knows? Who knows? But you're looking for the pair that happens to make a sum of that of B. Whatever this sum is down here in our bottom triangle, this B, that's the pair of factors we're looking for. It is from this pair that we are going to now fill in the wings, so to speak, of our box. There's a lot going on in here. I promise. It's going to be okay. We, at this point, will have all 4 locations, all 4 quadrants of our box filled in with numbers. The top from the product of A times C, the bottom from our B, and the wings come from the factors that we found of A and C that have a sum of that B bottom number. All right. So with those 4 numbers, we are going to build our final answer. Our final answer comes from our variable of choice in the problem, plus whatever your left wing is divided by your A number, times your variable X of choice, plus whatever your right wing is over your A number. And we're going to clean this up, and for this particular lesson, because our leading coefficient is 1, because our A number every time is 1 for this lesson, what we are going to see is a final answer of X plus our left wing times X plus our right wing. That's how this is going to work. So let's begin some examples together. Here in example 1, we're going to factor our first trinomial of this lesson. Using our standard quadratic function, we have to determine our A, B, and C numbers. So there's no visible coefficient in front of your H squared, so we know A has a value of 1. B has a value of 8, and C has a value of 15. It's time for our first graphic organizer. So here's our box with a big X through it, and we know that on the top is always going to be A times C. And for this particular problem, A is 1, C is 15. So 1 times 15, well, that's clearly 15, and that lives in the top of your box. At the bottom of your box is going to be your B value. So my B value was 8. Graphic organizer number 2. So at the top of this T-chart is the 15 that was living in the top of our box. So we say, okay, what are all the things that could multiply together to make 15? Acknowledging that this 15, looking at our A, B, and C numbers, happens to be a positive 15. Great. So a positive 1 times a positive 15 would make 15. And so also a negative 1 times a negative 15 would make a positive 15. 3 times 5, a positive 3 times a positive 5 would make a positive 15. And a negative 3 times a negative 5 would also make a positive 15. So now it's time to add all 4 of these pairs of factors together to see what their sums are going to be. So 1 plus 15, 16. Negative 1 plus negative 15, negative 16. 3 plus 5, 8. Negative 3 plus negative 5, negative 8. We were reminded that our B number, the bottom of our box, is an 8. Hey, here is a sum of 2 factors that is also a positive 8. So acknowledge this is a positive 8, that one's a positive 8, which is why I'm not going to use this bottom pair of factors. Great. So it is these 2 factors, the 3 and the 5, that we're going to put in the wings of our box. What if you have them switched? So I had a 5 versus a 3. Not a problem. It really does not matter at all. Let's go find our final answer and clean this up. So we have a variable of choice that is an H. And we have our left wing, which is a 3, over our A number, which is a 1, times, again, our variable of H, plus our right wing, which is a 5, over our A number of 1. So to clean this up, we would have the quantity of H plus 3 divided by 1 is 3, times the quantity of H plus 5 divided by 1, which is 5. And there you go. Now, hey, how do I know if I've done this correctly? You can totally check that out. If you were to multiply all of these back together using binomial multiplication, if you've done this correctly, you should have your exact original function in the problem. There you go. Here in example 2, let's grow our skills in factoring a trinomial. Using a standard trinomial as a guide, we see that again our A number is still 1, our B number is 5, and our C number is 6. Using our first graphic organizer, we are going to again multiply A times C on the top of our box, where that was a 1 and a 6. So 1 times 6, well, that's 6. And at the bottom of our graphic organizer, the bottom of our box, we have our B number, which is a 5. In our second graphic organizer, we remember to place our value, our product that we got from A times C, which is here in the top of our box, 6, on the top of our T-chart. And again, as there are only positives in this particular trinomial, we know this is going to be a positive 6. So let's go find the factors of positive 6. That could have been 1 and 6. That could have been negative 1, negative 6. That could have been 2 and 3. That could have been negative 2, negative 3. So let's go find their sums and see what we can explore and create together. So we've got 1 plus 6, which makes 7. Negative 1 plus negative 6, which makes negative 7. 2 plus 3, which is 5. And negative 2 plus negative 3, which is negative 5. Hey, do you see what we need? I see it. Hey, we found it. So we needed the B number to be the sum of the 2 factors that we're looking at. And we're going to use those factors here in the wings of our box. So we've got a 2 and a 3 in the wings, and you might be asking, hey, could I have that 2 and that 3 switched? Sure, not a problem. Not a problem at all. So let's go find out what our answer is going to be. We have our variable of choice here in the problem of a z. These are all positive numbers, plus our left wing over our a number, times, again, our variable of choice, plus our right wing over our a number. And let's clean this up. So I end up with a final answer of the quantity z plus 2 times the quantity z plus 3, as anything divided by 1 is just that original thing. And there you go. Here in example 3, as we go to factor this trinomial, we realize that this time, hey, there's a minus. So let's go see what it does. Using our standard trinomial as a guide, we see that again our a number is 1, our b number is 22, and our c number, ooh, that is a negative 23. Hey, do you have to take that negative with it? You bet you do. Absolutely have to take that minus along with the 23 as we work through the factoring of this trinomial. Here in our first graphic organizer, a times c, still on the top. So I have 1 times a negative 23. So a positive times a negative is a negative. 1 times 23 is 23. In the bottom of my box is still b, and that is a positive 22. That's going to be important. With my second graphic organizer, we need to dissect negative 23. There are not a lot of options to factor negative 23. There's just not. It's prime. It is prime 23. But because it is negative, that changes things up just a tiny bit. That could have been negative 1 times a positive 23, or it could have been a positive 1 times a negative 23. So let's see what that does. So we've got negative 1 plus 23. That makes a positive 22. Versus positive 1 plus negative 23. That makes a negative 22. And we see here in our problem, in our box, that we actually need a positive 22. So this first factored pair of negative 1 and positive 23, that's who you want. So our negative 1 is going into a wing, and our positive 23 are going into a wing. And yeah, again, you can have them switched as long as wherever you have that 1, it's negative, and wherever you have that 23, it's positive. Okay, so let's go find out what our final answers look like. We have our variable of choice, v, minus. So there's a couple ways to look at this. In the original setup for the problem, I always had a plus, and that can still stand. But it means that our left wing is a negative 1 divided by our a number, which is a positive 1. And we have also, again, our v for our variable, plus our right wing divided by our a number of 1. So when we clean this up, we end up with v minus. Negative divided by a positive is a negative. A positive and a negative side by side, multiplying together makes a minus. 1 times v plus 23. And there you go. Here in example 4, we're going to factor this given polynomial. And this time we see that 2 of our 3 terms are negative. Let's see what happens. So again, using the standard form of a quadratic, we look and find our a, b, and c numbers. A is 1, b is negative 12, and c is negative 13. Let's fill in our graphic organizer. Top triangle, a times c, 1 times a negative 13. So that gives us negative 13 in the top of our box. In the bottom of our box, B, which happens to be a negative 12. In our second graphic organizer, we're putting our negative 13 on the top of our T-chart, and let's find all of the pairs that could multiply to make negative 13. So we could have a negative 1 times a positive 13, or we could have had a positive 1 times a negative 13. So let's go add them together and see what we get. So let's see, negative 1 plus 13 gives me a positive 12. And positive 1 plus a negative 13 gives me a negative 12. Do you see what we need? There's the negative 12 that we need. Let's go put it in the wings. So we've got 1 in the left wing and negative 13 in the right wing. Let's go place these into our parentheses. So our variable of choice is an F plus my left wing, which is a positive 1, divided by my A number of 1. Again, for my second set of parentheses, my variable of choice, which is an F, and I have my right wing of negative 13 over my A number of 1. Let's clean this up. So 1 divided by 1 gives my first quantity a result of F plus 1. In my second quantity, I have F, so a negative divided by a positive, well, that's a negative, sure. But a negative and a positive side by side multiplying, that's a negative 13. And then we close that set of parentheses, we close that quantity, and there you go. In our fifth and final example, we're going to factor this quadratic where I have a negative B term and a positive C term. Let's see what happens. So our A is 1, our B is negative 9, and our C is a positive 18. Using our graphic organizer, multiplying A times C to fill in the top triangle, we have 1 times a very positive 18, making a positive 18. And in the bottom of our box, we have B, which is a negative 9. In the T-chart, if we have 18 up at the top of it, we say, okay, that is a positive 18. And this is where the factoring becomes really important to acknowledge. So I've got positive 1 times positive 18, or I have negative 1 times negative 18. I have positive 2 times positive 9, or negative 2 times negative 9. And I have positive 3 times positive 6, or I could have had negative 3 times negative 6. It is important to look at all these different possibilities of factors, because that's where your answers are going to come from. So 1 plus 18, 19. Negative 1 plus negative 18, negative 19. 2 plus 9, 11. Negative 2 plus negative 9, negative 11. 3 plus 6, 9. Negative 3 plus negative 6, negative 9. Did you find your guy? Hooray, we found him. So this is just a really great example as to how important it is to go through all of the factors, positive and negative, acknowledging what's happening with all three of your terms. Okay, let's finish this up. So variable of choice is an S plus my left wing of negative 3 divided by my A number times the quantity of S plus my right wing of negative 6 divided by my A number of 1. Let's finish it out. S, a negative divided by a positive is a negative 3 times the quantity of S minus a negative divided by a positive is again a negative 6. And there you go. Remembering that with each and every one of these problems, you can always check them by multiplying out your final answer using binomial multiplication to check and see if you get back what you had in the original problem. And there you go.